Today's lesson is 4.8. We're going to talk about similar figures. So we're going to go through the vocabulary words first. Similar figures is when you have two shapes that have to be the same shape, but they're not necessarily the same size. So we have a new symbol here, the similar to symbol. So two figures are similar if the corresponding angles are congruent, if they're the same measurement, and also the sides have to be proportional. So we're going to be still solving some proportions for this chapter. Alright, so it talks about corresponding angles. Corresponding angles are angles that are in two similar polygons and are in the same relative position, so they're the same spot. So in the two that I see here, E and B are corresponding angles. A is going to correspond with D, and then last but not least, F is going to correspond with C. So there's three different angles and they all have one to correspond with. Corresponding sides, mine's color-coded, so you can kind of see that a little bit better than on yours, but you can see line AC corresponds with DF, and then AB is corresponding with DE because they're in the same position, and then BC is corresponding with EF. So a little confusing, but if they're in the same part of the shape, then they're corresponding. So let's do a couple of examples to try to make sense of all that. So I'm going to draw two triangles in my example 1 spot. Okay, so I have two triangles and I'm going to give you some dimensions. I'm going to say that 9, 12, and 6 for this first triangle. The second triangle is 3 by 4 by 2. So what I need to do, I don't know anything about the angles, okay? So we're going to see if the sides are proportional. So notice that 12 is the longest side and 4 is the longest side. So I'm going to name this A and I'm going to name this triangle B. So I'm going to write a couple ratios comparing triangle A to triangle B. And I always look for parts that I know are corresponding. So if they're both the longest side, I know they are corresponding. So I'm comparing 12 to 4. I also notice that the 9 and the 3 are corresponding. So I'm going to set up another ratio comparing the 9 and the 3. I know these are, or I can figure out if they're proportional by looking at their cross products. So 9 times 4 is 36, and 12 times 3 is 36. So that was a yes, right? Because those two parts are corresponding. I'm also going to check the shortest side. So I just want to double check that everything is proportional. So again, I'm comparing the longest side to the longest side of triangle B. And I'm also going to compare the shortest side. So the shortest side on this triangle is 6, and the shortest side on that triangle is 2. So I have 6 to 2. Alright, again I can check to make sure everything's proportional, because I have 6 times 4 this time, which is 24. And I also have 2 times 12, which is 24. So tell whether the triangles are similar. Yes. And your worksheet will give you angle measurements, and that'll tell you the angles are congruent, because that's the other condition to be similar. Okay, under example 1, let's try another one. Again, we're comparing triangles. So I'm going to make another triangle and another triangle. So I have 3, 7, and 5. And then I have 15, 28, and 20. Again, I like to name like this one A, and I like to name the other one B. Doesn't matter which order. So that when I set up my ratios, I'm always comparing one triangle to the other triangle. Again, I like to look for my longest side. So on this triangle, I see the longest side is 7, and the longest side is 28. So the longest sides are 7 to 28. For the shortest side, I see the shortest side on A is 3, and the shortest side on B is 15. So I'm comparing 3 to 15. Now when I check my cross products, I'm looking at 3 times 28, which I believe is 84, and then 7 times 15 is 105. So right away I see that these are not equal, so that means no. These two triangles are not similar because their sides are not proportional. Moving on to example 2. Now we get to look at four-sided figures. So this is a little bit easier because it's easier to pick out your corresponding parts. I'm going to go ahead and tell you this is a rectangle. Okay, so I know my angles are congruent, so I'm not worried about that. But I need to make sure the sides are proportional. So the first rectangle I made 5 by 7. And this one I'm going to make 1 by 2. Again, I'm going to go ahead and give this one A and a B name. So when I set up my ratios, I'm comparing A to B. I'm also going to keep with the theory. I want to compare the longest side to the longest side. So I know I'm comparing corresponding parts. For the shorter side, I have 5 to 1. So equals 5 to 1. Testing my cross products, I have 10 and I have 7. I see that those do not equal, so that means no. These two quadrilaterals are not similar.